Hello students, in this session we will learn the mining algorithms. So before studying the mining algorithms we have to understand the concept of proof of work. So we will take the introduction of proof of work. In second part of the unit we have to study this proof of work in detail. Proof of work is a algorithm for consensus in the Bitcoin or blockchain network. So what is consensus mechanism? We have studied in the unit 1. So we will start with the task of miner, what we have studied in the previous session. So we have studied the task of miners in previous session. Miners is nothing but the node that validates transactions on the uh, Bitcoin network. So miner has different functions in the Bitcoin network that we have studied in the previous session also. First function of the miner is syncing up with the network. So when a node will join a Bitcoin network, first this node has to download the blockchain from the other nodes, and if the miner has the copy of ledger, then the miner can do the various operations in the uh, Bitcoin network. Then uh, second task of miner is transaction validation. Transactions are broadcasted on the Bitcoin network, and that transactions are validated by the full nodes by verifying the digital signatures and outputs. So the main function of the transaction is verification of the main function of the miner is verification or validation of the transaction. Uh, then next task of miner is block validation. Miners and full nodes can start validating blocks. Whatever the blocks the miners will receive from the other nodes by evaluating that blocks against certain rules. That blocks are validated by the miners, and this validation includes verification of each transaction. Transaction is verified against certain rules. We have studied the different rules to verify the transaction, along with the verification of nonce value. Then next task of miner is create a new block. Miners can create a new block. Miners propose a new block by combining the transactions in the broadcaster on the network. Whatever the transactions are broadcasted on the network, miner can put that transactions in block, and a block can be created. And if the block is validated by other nodes, then that block can be added in the uh, Bitcoin network. And then the next task, the fifth task of miner is perform proof of work. This task is the core of mining process. That is where miners find a valid block by solving a computational puzzle. Miners perform proof of work, and for performing a proof of work, miners solve a mathematical puzzle. And for solving the mathematical puzzle, miners spend enough lot of computing power. The hardware should be uh, fast enough to perform the proof of work. And uh, for solving this mathematical puzzle, the block header contains a 32-bit nonce field, 32-bit nonce value, and miners are required to repeatedly vary this nonce value until the resultant hash is less than a predefined target, difficulty target, that whatever the hash is produced, that hash should be less than the predefined target. Uh, uh, then we can say that this proof of work is completed. This proof of work algorithm is satisfied. And once a node solves the hash puzzle, the next task of miner is once a node will solve the hash puzzle, the mathematical puzzle, it immediately broadcasts the result. It will broadcast the results to the other nodes. Other nodes will verify it and accept the block. Once the block is accepted, the miner will get a reward of 12.5 bitcoins. So in 2020, these rewards are decreased to 6.25 every 4 years. Uh, the rewards will decrease, as we have studied in the uh, previous session. So rewards are nothing but the transaction fee miners will get for performing the proof of work. So in unit 1 we have studied the consensus mechanism. Consensus mechanism is for verification of the transaction in the Bitcoin or blockchain network. So before adding the transactions in the block, that transactions are verified against certain rules, and if the transaction satisfies certain rules, it is as per the rules, then that transactions are added in the block. So after verification of the transaction in the Bitcoin network, our next task is adding a block in the blockchain. In Bitcoin network, who will add the block? So miners can create a new block, and miners can add a new block in the blockchain network. So in Bitcoin network, the mechanism is designed in such a way that malicious node, attacker node should not be able to add the block in the blockchain Bitcoin network. So there is a control on the thing that who can add the block in the blockchain Bitcoin network. So for adding the block, miner node has to spend lot of computational resources. The hardware of the node that will add the block should be strong, it should be faster, efficient, and it should have a lot of computational power. That node can is only able to add the new block in the blockchain network. And there is a rule we have studied in the previous session. For adding the new block in the block Bitcoin network, for adding the new block, it should take at least 10 minutes time, 10 minutes fixed time for adding the block. So why this restriction is put on the time? The restriction is put for the purpose that uh, this is for security purpose. So at least 10 minutes should be required to add the block in the Bitcoin network. And for adding the block, the nodes has to solve the mathematical puzzle. That mathematical puzzle is nothing but the proof of work. And for solving the mathematical puzzle, nodes has to node has to spend a lot of computational power, energy, and efficiency also. And after spending lot of computational power, node can add the block in the blockchain Bitcoin network. So for adding the new block in the blockchain network or Bitcoin network, nodes compete to each other. Many nodes will try to solve this proof of work, this mathematical puzzle. And node, now who will win? Who will solve the this proof of work puzzle? That node is able to add the block in the blockchain Bitcoin network. So this proof of work mechanism ensures that the malicious node will not add the block in the blockchain network. And if malicious node wants to add the block in the blockchain Bitcoin network, then malicious or attacker node has to spend lot of resources. The malicious node has to perform lot of computations, and it has to solve this mathematical puzzle. And if some block is changed, some transactions are changed, then malicious node has to change the hash of all previous blocks, and it should take a lot of time and lot of computational resources to add the node for malicious node. So this is the mechanism devised by the uh, designers of Bitcoin network. So in coming session, we have to understand the concept of proof of work. The purpose of this session is to study the mining algorithm. Just we will take the introduction of this proof of work. So this proof of work is a proof. This proof of work is a proof that enough computational resources have been spent in order to build a valid block. So this is the proof that the node has spent enough resources, lot of computational resources, lot of energy that the node has spent have been spent to add the block in the Bitcoin network. So proof of work is based on the idea that a random node is selected every time to create a new block, and this random node needs to be solved the mathematical puzzle, and for solving the mathematical puzzle the node has to spend lot of computational resources, and this is the mechanism that the node has spent enough resources to solve the mathematical puzzle, and after spending enough resources the node can add the block in the Bitcoin network, and for this purpose node has to solve the mathematical puzzle. So in this model, in this proof of work, nodes compete with each other. Nodes will compete with each other in order to be selected for adding the block in the blockchain Bitcoin network. So why nodes compete with each other? Because nodes get a reward. Node get the incentive for adding the block in the Bitcoin network. So you can see students this proof of work formula that the nodes has to solve this proof of work puzzle. So following is the equation that works for proof of work. So following is the equation that sums up the proof of work requirement in the Bitcoin network. So you can see this equation. So in this equation it will calculate the hash value from the nonce hash value, and it will, for calculating the hash value it will use the nonce. Then you can see for calculating the hash value, n is the nonce, this nonce. Then you can see pcache, you can see this n is the nonce, and pcache is the hash of the previous block. So you can see this hash of the previous block, and tx represents the transactions in the block. So block has multiple transaction, and the hash value is calculated from the nonce. These terms are combined. We can say concatenated nonce value. You can see this nonce, then this hash of the previous blocks, and transaction. List of the transaction is there, number of transactions are there. All these terms are concatenated, combined, and from this the hash value is calculated. And this hash value, this resultant hash value, whatever the hash value is calculated, this hash value should be less than the difficulty target. Resultant hash value should be less than difficulty target. You can read this sentence. This means that the hash of the previously mentioned concatenated fields, whatever the hash hash we have calculated, this is the hash we have calculated from by calculating the different fields. These are the fields nonce, this hash of the previous block, and then transactions. From this by combining these various fields we calculate the hash, and this hash value should be less than the target hash value. And if this hash value is less than target value, and then that means this proof of work mathematical puzzle is solved. And for solving this proof of work mathematical puzzle, the nodes requires a lot of computational power, and the only way to find these nonce, only way to find the correct hash value that will remain less than the target hash value. For that purpose, we have to find a nonce value, and that nonce value we can find by using the only uh, uh, brute force method. We have to try the lot of different values for calculating this appropriate nonce. Once a certain uh, uh, pattern of a certain number of zero is met, once a certain number of zeros we get, then by miner the block is immediately broadcasted. That means the mathematical puzzle is solved, and the block is broadcasted and accepted by there must be a certain number of zeros in the uh, hash value that we calculate. That hash value should be preceded by a certain number of zeros. So this is the proof of work. So in coming sessions we will study more about this concept. Our main aim of this session is to study the mining algorithm. So mining algorithm is nothing but uh, uh, for mining purpose, mining is nothing but solving the mathematical puzzle, and after mining the node will be able to add the block in the Bitcoin network. So for adding the block in the Bitcoin network, node has to perform lot of work, and we will see how the node will perform different steps to add the block in the Bitcoin network. So for a mining algorithm, in mining algorithm, the first step is the previous block's header is retrieved from the Bitcoin network. So it will first the node will retrieve the previous block's header from the Bitcoin network, and as we know that previous block contains nonce value, then it contains list of transactions, and from that we calculate the hash value. So second step of this mining algorithm is assemble a set of transactions broadcasted on the network into a block to be proposed. In this algorithm, our aim is to find a hash value, that should be less than the difficulty level. So for this purpose, in previous proof of work equation we have studied, we need to combine different fields. We need to combine nonce, then hash of the previous block, and transaction that we want to add. From that transactions, that transactions are combined, assembled together, and from these various fields, nonce, hash of the previous blocks, and transaction that we have to add in the block, from that the hash value is calculated, and that hash value should be less than the difficulty target. And if that hash value is less than difficulty target, that means that proof of work puzzle is solved. So next, third step is you can see compute the double hash of the previous block's header. We have to calculate the hash value, and that hash value is calculated with the nonce, as we have seen in the previous slide. Nonce, then hash of the previous block, and the transactions that are proposed to be added in this block from that different three fields: nonce, hash of the previous blocks, and transaction. The hash value is calculated, and next task is to check if the resultant hash is lower than the current difficulty level or current target level. If we have to this mining algorithm check whether the resultant hash, whatever the hash we have calculated from the nonce, hash of the previous block, and then transactions, whatever is this resultant hash, this mining algorithm will check whether this resultant hash is lower than the current difficulty level, and if it is less than current difficulty level, that means proof of work puzzle is solved. Proof of work mathematical puzzle is solve, and as a result of this successful proof of work, the discovered block, whatever the block is constructed, that block is broadcasted to the network. And after broadcasting the block in the network, other nodes will validate the block, other nodes will agree on the block, and the miner will get reward. The node who will solve this puzzle uh, will get the reward. So as a result of this uh, mathematical puzzle, the miners will get a reward, and the miners will be able to add the node in the blockchain network. So this new block is broadcasted, and no other nodes will accept the block, and block is added in the blockchain. So these are the steps of mining algorithm. So the next concept in this technology is that 32-bit nonce value is there, and this 32-bit nonce value is exhausted, and as a source of extra nonce, as we need the extra nonce, for that purpose coin-based transaction is used. The coin-based transaction concept is added in the Bitcoin network. So you can read this sentence carefully. As the hash rate of the Bitcoin network increase, as the hash rate of the, we will see in the next slide what is this hash rate. As the hash rate of the Bitcoin network increase, the total amount of 32-bit nonce was exhausted. So this 32-bit nonce value is not enough. It can be calculated easily. So in order to address this issue, the extra nonce solution was implemented. We need the extra nonce, whereby coin-based transaction is used. Coin-based transaction is used as a source of extra nonce to provide a larger range of nonce to be searched by the miner. So 32-bit nonce is sufficient. We have to increase the length of the nonce. We need the extra range for nonce, and for that coin-based transactions are introduced, and coin-based transaction provides a larger range of nonce. This is the concept. So in previous session we have studied the mining algorithm. Same thing we are trying to understand with the help of diagram. So in this figure, students, you can see mining algorithm is explained. So how mining is done, that is shown in this diagram. For mining, we require a previous block shader, and from previous block shader we get the nonce, nonce, then hash of the previous block we get, and we need the transactions in the new block. Whatever the block we will propose, in that new block we have to assemble the transactions. We have to combine the transaction. Block contain number of transactions. That transactions are gathered, and that transactions are put in the new block. And from this transactions, then nonce and hash of the previous block, this mining algorithm will generate a hash. It will generate a hash. After generating the hash, the next step is, you can see the next step, it will check the hash. If hash is less than the target hash, if the hash is less than the, you can see this block, it will check if hash is less than the target hash, and if hash is less than whatever the hash, resultant hash, whatever the hash we have calculated, it will check whether that hash is less than the difficulty target, and if it is less than difficulty target, then it will publish the block. It will broadcast a block in the network, and if the other nodes will accept the block, and it will fetch the reward. The miner will get the reward for adding the block in the blockchain network. And if the hash is not less than target, if the this mathematical puzzle is not solved, you can see if the hash is not less than target, then it will increment the nonce. It will increment the nonce, and after incrementing the nonce, uh, the algorithm, you can see the algorithm will uh, again generate a hash value, again calculate the hash value. So it has to vary the nonce, it has to vary the nonce in such a way that the resultant target resultant value is less than the difficulty target. And for this purpose, this mining algorithm has to vary the nonce, and for this purpose mining algorithm, the node on which this mining is done, that node has to spend lot of resources. And after spending lot of hardware, after spending the lot of energy, the node will be able to solve this mathematical puzzle. Block is created and block is added in the blockchain, and at least node should take 10 minutes time, minimum 10 minutes, which is a fixed time of 10 minutes that node has to take for solving this mathematical puzzle. So this is for security purpose. The any malicious node should not be able to add the node in the blockchain, and if the any malicious nodes wants to add, uh, it has to spend lot of hardware, lot of energy. It has to change every hash, and it should not be possible for malicious node to add the block in the Bitcoin network. So this is the mechanism that is for security of the Bitcoin. As we know that students, for adding the block in the Bitcoin network, the node who will add the block, that node requires lot of hardware, and as the hardware become powerful, mining difficulty increase. So as we know that the computers day by day become powerful, and because of that, the Bitcoin network increase the mining difficulty. As the computers become powerful, they can solve the mathematical puzzle in less time. And but as per the rules of Bitcoin, there should be the miner should take at least 10 minute time, the 10 minutes fixed time to solve the puzzle. So they have increased the difficulty level of puzzle, so that despite of the thing that the hardware become powerful, the miner should take 10 minutes time to solve the mathematical puzzle. So you can read mining difficulty increase over the time. This mining difficulty increase over the time, and Bitcoin that could be mined by single CPU. Laptop computers have required dedicated mining centers to solve the puzzle. So solving the puzzles, the miners required lots of hardware and lots of resources, and uh, the hardware become powerful, and miners can easily solve this puzzle. So for that purpose, the Bitcoin has increased the difficulty level of this puzzle. The reason why the mining difficulty increases is because in the Bitcoin, the block generation for generating the new block, it has to take always around 10 minutes. This means that if the blocks are being mined too quickly by fast order, if the blocks are mined too quickly by hardware, it means that blocks will that nodes will take less than 10 minutes time. So this is not allowed. So for that purpose, to keep this time fixed, we have to increase the difficulty level of puzzle. So this is all the restriction put by the Bitcoin network. So this is, we can say in reverse, if blocks are not mined every 10 minutes, then that means the difficulty level of puzzle is decreased. So if we say in reverse manner, if the block is not taking 10 minutes time, uh, to add in the blockchain, that means difficulty level of the mathematical puzzle is decrease, and this is not allowed. The mathematical puzzle should be difficulty enough, and it should take at least 10 minutes time for any node to solve this mathematical puzzle. So hash rate also increase. So as the computers become powerful, hash rate also the time required for calculating the hashes per second. The hash rate is nothing but the time required to calculate the hash per second. And as the computers become powerful, the time required for calculating the hash value is also decreased. So uh, so to avoid this, the hash rate is also increase. In other words, the difficulty level of calculating the this hash value is increased. So in other words, this is the speed at which in the miners Bitcoin network are calculating the hashes to find a blocks. So in early days of Bitcoin, it used to be quite small. CPUs are not much powerful. The time required for calculating the hash is quite small. But nowadays computers become powerful, and supercomputers are there. Other dedicated specialized computers are there. So for that purpose, uh, this time required for calculating the difficulty level is increased, and time required for calculating hash is decreasing day by day because the thing that the computers become powerful. But we have to keep this time in such a way that the computer will spend lots of computational resources, and it will take enough time to calculate this hash value. This is for security of the Bitcoin network or blockchain network. So mining system is nothing but a computer system that will perform the task of mining, that will run a mining algorithm, that will solve a mathematical puzzle, and that will compete in the process of mining, and it will solve the puzzle. And after getting solving the this mathematical puzzle, the miner will be able to add the block in the blockchain. So over the time, the Bitcoin miners have used various methods to mine the Bitcoin, various different types of computers, and for mining purpose, the node has to calculate the uh, double hash double SHA-256. It has to use this SHA-256 algorithm, uh, and expert for solving the mathematical puzzles. The expert have developed sophisticated systems to calculate the hashes faster. But as the Bitcoin rule of the Bitcoin, it should take at least 10 minutes time to solve the mathematical puzzle and to add the new block in the blockchain network. The first in early days, CPU, laptops or general purpose computers are used for mining purpose, and users could have even used laptops or desktop computers to mine bitcoins. Now CPU mining is no longer profitable. Difficulty level of solving the mathematical puzzle has increased, and using the CPU for mining is not profitable. Now more advanced mining machines, the hardware become available, such as ASIC based mining is used. CPU mining lasted for around just over a year, and since after introduction of Bitcoin, this CPU mining, the general purpose computers, laptops are used for mining purpose up to 2010-11, and soon after that, this method of using computers or laptop is explored, and more powerful hardware is needed for mining purpose. So general purpose unit GPU, this has graphics card. This is more faster than the CPU, and this supports faster and parallelized calculations that are usually program using OpenCL language. So this type of computers are used for doing the mining task after the CPU. FPGA, this is the field programmable gate array. This is GPU mining did not last long, and soon miners found alternate way to perform mining using FPGAs. And FPGAs is basically an integrated circuit that can be programmed. It can be programmed. This FPGA can be programmed for specific purpose, and it uses a specific programming method, that is hardware description language is used, such as a Verilog or VHDL, and double SHA-256. Double hash can be calculated more faster by using this FPGA. So after GPU, this FPGA type of hardware is used for mining purpose. After that, these FPGAs are also get exhausted, and after that application specific integrated circuit was designed to calculate the SHA 256 hash, double hash. So these special chips, ASIC, the special chips were sold by various manufacturers and offered a very high hashing rate. So this worked for some time, but due to the quickly increasing, as the Bitcoin network is increasing the mining difficulty level, this ASIC also become useless, and these are no longer profitable to use this ASIC integrated application specific integrated circuits for calculating the hash values. So mining pool, in mining pool, as the difficulty level increase, so it is not sufficient that one node, one computer will calculate the hash values, and one computer will perform a mining task. So for performing a mining pool is used. Mining pool means group of computers, group of miners that work together to mine a block. So group of computers are used for mining purpose, and for managing this group of computers, managing the pool of these computers, there is a pool manager. That will control overall operation. Pool manager will receive the coin-based transaction, and if the block is successfully mined, that means if the group of work puzzle is solved, this group of pool manager is responsible for distributing the reward, for distributing the incentive among the group of computers, the group of miners who invested their resources to mine the block. So this is profitable as compared to a solo mining. Solo mining means the mining done by the individual machine, individual computer. So where only one node, where only one computer machine is trying to solve the mathematical puzzle. So instead of only one machine trying to solve the mathematical puzzle, number of computers, number of machines are working together to solve the mathematical puzzle. Pool of computers, and there is a pool manager that will control overall operation. And if the pool manager, if the block is successfully mined, all the nodes, all the computers that participate in this process of solving the mathematical puzzle, that computers will get that nodes will get the mining reward. So this is the concept. So students, thanks for watching session. In this session we have taken a introduction of proof of work. We have studied the mining algorithm. The purpose of this session is to understand the mining process, mining algorithm, and we have studied as the computers become powerful day by day, as the mining difficulty is also increased, and for the level of solving the puzzle, mathematical puzzle, that difficulty level increase, and so we require a powerful hardware. So initially general purpose computers are used, then we have studied GPU that has the graphics card that can do parallel operation, then ASIC, FPGA, and then the number of computers can work together to solve the mathematical puzzle, to solve the proof of work puzzle that can be used. So this is the typical concept of proof of work. In one lecture you may find difficult to understand this concept of proof of work. So as we progress in the in this syllabus, in this subject, we will you will the things that will become clear to you. So thanks for watching session. Today we will stop here.